Today's video is on integration using residues. In today's video, we are going to find the poles of e power iz by z square plus 1 and the corresponding residues. See here from the question, our f of z is given as e power iz by this is z square plus 1. Now we have to find the poles for this given function. So in order to find the poles, we have to equate the denominator to 0. Here the denominator value is z square plus 1 is equal to 0. And here this can be written as z square minus this is I square is equal to 0. So as I square value, you know that it is minus 1. Minus of minus, this is plus 1. So now this is of the form a square minus b square. So this can be written as this is a plus b into this is a minus b is equal to 0. Now if I equate z plus I to 0, see what happens. So z is equal to minus I. So if I equate z minus I to 0, we got z is equal to plus I. Therefore, z is equal to, so z is equal to plus or minus I are the simple poles for this given function f of z is equal to, f of z is equal to e power iz by z square plus 1. So clearly z is equal to minus I. So z is equal to minus I and z is equal to plus I are the poles for the corresponding function f of z is equal to e power iz by z square plus 1. Now we have to find, the residues. So residues for the given function. In order to find the residues, see here the formula is very simple. That is residue of f of z at point z is equal to z naught is nothing but limit z tends to z naught. This is z minus z naught into f of z. Clear? Here are z naught value. I am taking this as first one. I am taking minus 1. So residue of f of z at point z is equal to minus 1 is equal to limit z tends to minus I. This is z minus of minus plus I into f of z. So what is our f of z value? So f of z can be written as, so here this can be written as f of z is equal to, this is e power iz by, this can be written as, so we have to use these pole values, that is z plus I into this is z minus, so this is z minus I. Now I am writing the same thing, that is e power iz by, this is z plus I into this is z minus I. Now after cancelling these two, I am substituting z value as, see here z is equal to minus I into e power iz by, this is z minus I. After substituting z value as minus I, see what happens. This will be minus I square by, this is minus I, this is minus I. So this value is nothing but e power minus 1. So this is minus of minus plus 1 by, this is minus 2. So this value is minus 2. This is minus 2I here, and therefore this minus I am bringing to the numerator and I am writing as I square e by, this is 2I. So if I cancel 1I, this will be, so this can be written as residue of f of z at point z is equal to minus I value is equal to ei by 2. See, this value is ei by 2 or ie by 2. So this is a residue value for the pole z is equal to minus I. So this value, it is I. This is not 1. This value is I. See, so we have to cancel z plus I from the numerator as well as denominator, and we have to keep minus I in place of z. After keeping minus I, this is I into I. So this is minus I square. I square value is minus 1, and again this is minus, this value is plus 1. This is minus 2I. So for minus I am bringing to the numerator and I have written it as I square. So after cancelling I square, so this is ei by 2 is the residue value for the corresponding pole z is equal to minus 1. For the next pole here, z is equal to I plus I. So here for the pole value, again our residue value here will be the residue of f of z. See, residue of f of z at point z is equal to z naught is equal to, this is limit z tends to z naught. This value is z minus z naught into this value is f of z. And here our residue value for this is, I am taking residue value as z is equal to plus I here. That is limit z tends to I, z minus I into f of z. So our f of z value is nothing but, see, what is this f of z? So this value is f of z. And in the next step, limit z tends to I, this is z minus I into, what is our f of z value? That is e power iz by, that is z plus I into this value is z minus I. Clear? So I can cancel this one. And now I have to substitute I in place of z, that is e power iz by, this is z plus I. So if I substitute this one, this will be I square by I plus I. So this value is nothing but e power I inverse by, this is 2I. So if I multiply with I in the numerator as well as denominator, this will be I into e inverse by I square is nothing but minus 1. So this will be minus 2. And therefore, this value is nothing but minus I by 2 into, so if I get E down, so this will be 2E. Therefore, this is the residue value of f of z at point z, at the pole value z is equal to 1. So we got the residue value as minus I by 2E at the pole value. So this is the corresponding residue value for the pole z is equal to I. So this is how we have to solve. This is also so important. Therefore, in the question, so we have to find the poles of this given function and the corresponding residue values. F of z is equal to e power I z by z square plus 1. So after equating the denominator to 0, so these are the simple poles, that is plus I and minus I. For minus I, so this is the residue value after substituting in the formula. And next one, for the residue value z is equal to plus I. So this is the residue value, that is minus I by 2E. So this is how we have to solve. If you follow these videos one by one, definitely you can have a grip in this whole chapter and you can score more in the examination. If you really understand, please practice, pass it on to your friends and subscribe to this channel. So please have a look at my next video too. That is also very, very important. And check the playlist once and go through all the videos. Thank you.